Let's look at y equals mx plus b. So when an equation is in that form, the m, or whatever number is attached to x, the coefficient of x, is always the slope. And the constant, which is being added or subtracted but not multiplied with the x, is always the y-intercept. So this is going to help us graph. So let's look at these examples. So y equals negative 3x plus 5. Slope is, and the y-intercept is 5. So you should be trying to answer these before me. So number 2, the slope would be the coefficient of x, which is 1/2. Don't let it fool you because of the x being turned around there. And the y-intercept would be positive 10. Number 3, the slope is 1, or you could say 1 over 1. The y-intercept is negative 9, not just 9. For number 4, the slope is 3, because the coefficient of x is 3. The y-intercept is 0. There's nothing there. It's plus 0. Same thing with number 5. So the slope, since there is no x, the slope is 0. And the y-intercept is 10. And we know the slope of 0 means it's a horizontal line. So that's what that line would look like. And it would be crossing the y-axis at 10. Now number 6 is a little different. Obviously it doesn't say y equals mx plus b. So this is a little bit different. This one I want you to look at that and think, okay, the slope is actually undefined, and the y-intercept, there isn't one. If I was to graph this line, if I was to make a table of values, I can make y anything I want, but x has to equal negative 3. And if I graph that on a x and y axis, that means I'm always going to the left 3 and up however many I want, or down however many I want. So if I graph a bunch of points at negative 3, 1, negative 3, 2, negative 3, 3, negative 3, 0, I end up with a vertical line. And we know 2 things about vertical lines. Number 1, their slope is undefined. And number 2, we also know that this is not a function, which is why it doesn't really adhere to the y equals mx plus b formula. So when you see an equation with no y, but just an x value, you know it's going to be an undefined or a vertical line. So this is just backwards. If I give you the slope of a line, and then I also give you the y-intercept of a line, you should be able to put it into an equation because it's always this formula. So the slope is the coefficient of x, which means we're going to replace m with negative 1/2. And the y-intercept is negative 6, so I'm going to replace the plus b with minus 6. All right, now we're going to move on and graph using slope-intercept form, because this is going to be a lot faster than using a table of values every single time. So every time you look at an equation, if it's in this form, which this one is, y is by itself is what I mean, it says y equals, then the coefficient of x is always our slope, and the constant is always the y-intercept. So in this case, it's positive 5. So start there. Start with the y-intercept being 5. Go to your y-axis, and let's put a point on 5. So 1, 2, 3, 4, 5, positive 5. And then from that point, we're going to count slope. So remember, slope is always the rise over the run. So as we rise 1, we're going to run 3. Now we want to end up with a negative slope. So just by imagining what it should look like when we're done, I'm going to kind of go off to the right here and kind of sketch. A negative slope decreases from the left side to the right side. So when I get done, my line should be sloping that general direction. You can think of it that way, or you can take that negative 1/3 and actually write it as either negative 1 over positive 3, or you can write it as positive 1 over negative 3. A negative fraction means one of the numbers is negative, the other one's positive. So let's start with negative 1, positive 3. So if I go down 1, that's what negative 1 tells me to rise, and positive 3, then I end up right here. So I'm going to sketch in a little stair step that I don't want to see in your graphs, but I'm going to show it in here. You actually wanted to go down 1, right 3. And now I'm going to do it again. Down 1, right 3. And that's where our next point goes. And now let's do the opposite direction. So now I'm looking at positive 1, so up 1, left 3, because negative 3 on a graph is left. And there's my next point. I'm going to actually go back and erase my stair steps because I don't like that. I just want to show the points that are actually on that line. Those stair steps were just helping me get to the next point. And I'm going to put in one more point. I'm going to go back to my upper left point there, and I'm going to go up 1 more and left 3 1 more, which would get me right here. Take a look at it when you're done. Make sure they are lined up, that you didn't miscount something. And let's put in our line. So it's definitely sloping negative. It's descending from the left to the right, and it's crossing the y-axis at 5. Let's do one more. Okay, slope is 2. Y-intercept is -4. I'm going to take that slope and rewrite it as a fraction. So it's rise 2 over 1. And since it's a positive, I could make both numbers positive, or I can make both numbers negative. So let's start with our y-intercept again. So I'm going to put a point on -4 on the y-axis. And then from that point, I'm going to start with my positive 2 over positive 1. So positive 2 on a graph means to rise 2, up, run 1 to the right. Again, rise 2 up, run 1 to the right. You should be on the x-axis on this point. Rise 2 up, run 1 to the right. And you can do this as much as you can fit. Now I'm going to go back to my y-intercept again and start over, and I'm going to do -2, -1. So rise -2 means to go down 2, and then left 1. And you can see it's nicely lining up with the rest of my points. So down 2, left 1. And fill in my line. And I started off by pulling out a +2 for the slope, so double check. I'm reading the graph from left to right like I read a book, and it's definitely increasing or ascending.